Welcome to the next day of electron configuration. Our objective for the day is we are learning to write the electron configuration of an element by using the periodic table. So far we have written the electron configuration using orbital diagrams, and we've also written the electron configuration based off of the filling order. But today we're going to look at how can we use the periodic table so that way we don't have to memorize everything. Quick review, potassium has 19 electrons. When we are filling in our orbital diagrams, we are starting at the lowest energy level, which is energy level 1, and we start in the lowest energy sublevel, which puts us in energy level 1, sublevel S. So there's the first electron. We look to see if there's another orbital in 1s. There's not, so we have to buddy up. It's full, so we have to go to the next box. Which rule tells us that we have to have two electrons with opposite spin to fill an orbital? If you thought the Pauli exclusion theory, you are correct. So I filled up 1s. Now I'm going to go to the next orbital. We want to fill in the lowest energy levels first. So that puts us in 2s. Which rule tells us to start with the lowest energy levels before we can move on to the next? If you said the Aufbau principle, you are correct. So we're going to 2s, filling that up, then to 2p. Now I have one electron in the 2p sublevel, but there are 3 orbitals in the 2p sublevel, which means my next electron is going into a different orbital, and so will the next before it pairs off. Which rule tells us that we want to fill in orbitals one at a time before pairing off electrons? This is Hund's rule. So I'm going to go quickly through. Those are the 19 electrons in my orbital diagrams. Now if I write it in electron configuration, it looks like this. Remember, the first term comes from my 2 arrows found in the first energy level in the S sublevel. And it continues on. So I have 6 arrows in my 2p sublevel. And finally, in the 4s sublevel, there's only 1 arrow. Remember, my coefficient is the energy level. My S represents what? It represents my sublevel, and those superscripts or exponents represent what? My electrons. So there's a lot of information in the electron configuration. We filled in a periodic table last week, and we noticed that there were a couple of patterns, and this periodic table kind of shows that. We see that there's an S block, a P block, a D block, and an F block. It shows us the order that we're following. It also shows us that we're kind of going in order. So as we go down, we go from 1s to 2s to 3 to 4s, 5s, so on. So our energy level increases as we go down the periodic table. So we can find the energy level or the coefficient of our electron configuration by looking at the period for that element. For example, what is the energy level for sulfur? Well, I have to find sulfur on my periodic table. Then I'm going to go over to the period of that element. The period is the row, so I'm going across my row, and then I see I'm in row 3, which tells me I'm in energy level 3. So what is the energy level for sulfur? It's 3. The next part of my electron configuration is my sublevel. So we can then add on the sublevel by matching the element to the correct block on the periodic table. So what is this sublevel for sulfur? Here's sulfur. And then my first sublevel is the S sublevel, which includes helium. My next sublevel is the P sublevel, where I find sulfur. The other sublevels are the D and the F sublevels. So what is the sublevel for sulfur? Sulfur is found in the P sublevel. The last part of my electron configuration is the number of electrons, or the superscript, can be found by counting the number of electrons in the sublevel, or the number of elements. So we had to find our element, sulfur, and we had to find the block, it's in the P block. When we're counting across, we're counting the number of elements that it takes to get there. So it goes 1, starting with aluminum, then 2, silicon, 3, phosphorus, and finally 4, sulfur. So how many electrons are in the sulfur's orbital? It would be 4 electrons. If we had gone further, we would have been in 5 or 6, but we stopped at 4, so that's why there are 4 electrons. So we can put this information together to write the last term of the electron configuration. And this is kind of like an address for the element, because each element has a different amount of electrons, so each element has a different electron configuration. Sulfur has a different amount of electrons than helium, so the electron configuration is going to be different. What was the energy level for sulfur? It was 3. Sublevel was P, and how many electrons? It was 4. So when we put this together, what is the last part of sulfur's electron configuration? The last part, or the last term, will be 3, P, 4. Remember, the 3 is my energy level, or the period. P is my sublevel coming from the block. And the 4 is how many elements over sulfur was found inside of that block. So I want you to find the last term of the following elements. I want you to pause the video until you have answered and filled in this chart. Once you have filled in the chart, go on to and you can start the video again. All right, hopefully you filled in all the blanks. The answers, well, first we have our energy level, sublevel, and then our number of electrons, which we put together. So we put them together to create our last term. Pause the video to check that you got the right answers. All right, so if you got the right answers, awesome. There are exceptions though. So exceptions to the rules. So that means this is the part that will be tricky. The first exception comes with finding the energy level of an element. Looking at the period number will work unless the element is in the D or F block. So if your element is in the D block, then your energy level will be N minus 1. So N represents the period number, so that would mean period number minus 1. If your element is in the F block, then your energy level will be N minus 2, where N represents the period number. Or if you've already memorized the order, you know that after 4s comes 3d, not 4d. So let's practice. Pause the video. All right, hopefully you filled in everything. So I filled in my first three columns. Remember, energy level. Iron was found in the D block, which is why I subtracted 1. Mercury was also found in the D block, so I subtracted 1. Which block was actinium found in? It was found in the F block, which means I have to subtract how many from my period. I had to subtract 2, which gets me 5. So when I put all of these things together, the energy level, sublevel, and number of electrons, I get my last term, which was 3d6, 4d10, and 5f1. So how can I use this to write the configuration? Well, you found the ending point, which is kind of like our element's address. But if I were to tell you my address was 762 Omar Street, that wouldn't tell you how to get from our school all the way to the house. So you have to figure out the directions on how to get there. And we're going to give very specific directions where you tell me the house at the end of each street. So you're going to have to start with hydrogen, and you'll tell me the house that ends on Hydrogen Street. So let's say I'm trying to figure out the full electron configuration for sulfur. I know that I'm going to end at 3p4. Well, my first orbital that I had to end at was 1s. So I ended at the 1s2 house before I had to turn and go on to the 2s sublevel and ended at the 2s2 house before I went on to the 2p sublevel, and I had to go over to the 6th house, which was neon, and then I had to go all the way to 3s2, and when I got to 3s2, I had to move over to 3p, and I finally end at 3p4, which is the last term. So I want to give you time to practice. You already found the last terms for each of these elements earlier on your worksheet. So I want you now to go back and fill in the full electron configuration using those last terms. I want you to pause the video and record your last terms. You should have recorded the last term of your electron configuration. It should look like this. Now I wanted you to go through using your periodic table to write the full electron configuration. Pause the video. You should have written out your full electron configuration, and here are the answers. I want you to pay close attention to the last 4. The last 4 include which sublevels, which make them different than the top 4. They include the D sublevel. Why is the D sublevel tricky? We have to remember that we're going to have a lower energy level than we expect by 1 in the D sublevel and 2 in the F sublevel. Alright, so how can we use the address to figure out the element? So when I give you an entire electron configuration, you can add up the superscripts to find the total number of electrons and find your element. Or you can look at the last term and find the element on the periodic table. So for example, my last term is 4p3. So this tells me to go to the 4th period, to the p block, and over 3 electrons, which will get me to arsenic, which is As. For your practice, I have given you some last terms, and I want you to figure out what the element is based off of the last term. So I have 3s2, I need